Don't forget that the recordings are available on Blackboard. They actually are YouTube, so you'll see. I mean, it's easy just to click on them, but you could see the URL there as well. So make sure if you missed a class, that you go back and watch the video so that you can keep up with the work. Now, I'm going to start with this example number 17, which was the example that we had given as homework. The 5 questions, well, actually, I don't know if they were homework, they were questions that you were supposed to have done in class. And number 17 was a particularly difficult example. It tells us that we want the equation of a line that's going to a point -4, -3, and perpendicular to the line -9x plus 5y equals 8. Let's go through this as thoroughly as we can, because on every final, on every midterm, there's going to be a question of this nature. So we have to know how to write the equation of a line given certain description of the line. Whenever we want to write the equation of a line, we're going to start to put it in the y equals mx plus b form. This is what we call the slope. The m is the slope, and the y-intercept form. The slope-intercept form is the y equals mx plus b form. And the first thing we're going to try and figure out about any line that we're writing the equation about is what is its slope. So we have to look at the description. The only thing it tells me that might help me with the slope is the fact that they gave me a line, -9x plus 5y equals 8, and they told me that my line, the line I want to write the equation for, is going to be perpendicular to this line. And we know that perpendicular tells us that the slopes of the lines are what we call either negative reciprocals or opposite reciprocals. In other words, I'm going to find the slope of this line, the original line. Let's call this line, I'll box it in red. We'll call this line 1. That's the original line they gave us the equation of. That is not the equation of the line that I'm looking for. It's the original line. Our line is going to be perpendicular. So what I'm going to do is I'm going to put this original line into the y equals mx plus b form, so that I will look at the number in front of the x, the coefficient of the x will give me the slope of this original line. That'll help me find the slope of my new line, because the slope of my new line has to be the negative reciprocal of this line. So in order to find the slope of this line, I'm first going to add 9x to both sides. That will give me 5y equals 9x plus 8. Remember, I always try to put the x term first and the number next. And then I'm going to divide by 5 to get the y alone. So this line 1, slope-intercept form is y equals 9/5 x plus 8/5. And therefore, the slope of this line is 9/5. Any question so far? Okay, if the slope of this line is 9/5, let's go to our new line. This is a line, let's call this line 2. This is the line that I'm trying to find the equation of. The slope of the original line was 9/5, so my new line has to have a slope that's, you flip it over and switch its sign, -5/9. That's what I needed, the fact that it was perpendicular to this line, because that told me what the slope of my new line is. So my new line is going to have an equation, y equals -5/9 x plus b. And the last thing I have to do is figure out what is the b of this line. What is the y-intercept? And that's where I use the point that's on the line. I know that the line, the point -4 and -3 is on my line, which means that when I stick in the numbers for x, -4, and for y, -3, that is going to give me a true statement. So I'm going to replace the y with -3. I'm going to replace the x with -4. And that'll help me find out what b is. Now, since I have fractions over here, remember what I usually tell you to do. Put the things over 1, the whole numbers. So therefore, you can keep track what is in your numerator, what's on the top and what's on the bottom. So rewriting this will give me -3/1 equals, well, remember when you multiply fractions, you try to cross out numerators with denominators, but nothing crosses out here, so you just multiply across. -5 times -4 is +20 over 9, 9 times 1, plus b over 1. And usually what I do is when I have fractions, to get rid of the fractions, I multiply everything in the equation by the common denominator. Now your denominators are 1, 9, and 1. Multiply those together, that gives you 9. Your common denominator is 9. So we're going to multiply everything, this whole equation, by 9/1. Now I'm going to erase this part over here because I just need the space. Continuing over here. Multiplying, I can still do this. 9 times -3 gives me -27/1, which is just -27. Oh, I'm sorry. Let me rewrite this. I'm going to be multiplying everything by 9/1. So this is going to be 9/1 times -3/1. 9/1 times 20/9 plus 9/1 times b/1. So here the 9/1 times the -3/1 gives me -27/1, which is just -27. Remember, when the denominator is 1, I don't have to put it in. Now notice in this one, there's a 9 on top and a 9 on the bottom, so they could cancel out. And I just have 1 times 20/1, so that gives me 20. And this gives me, nothing cancels out, 9 times b, which is 9b. And now if I bring the 20 to the other side, I will get -27 minus 20, which is -47. This cancels out, equals 9b. And divided by 9, So now I have what my b is. So now I can write my equation y equals m, which is negative 5 over 9, x, plus b, which is negative 47 over 9. I'm going to mute everybody, and if you want to say anything, please unmute yourself. It's just easier not to have outside interference. And this would be your answer if they asked you for the equation in what we call slope-intercept or y equals mx plus b form. Y equals negative 5 over 9, x minus 47 over 9. Now, if you really looked at this question, though, what it asked for was write the equation in standard form. So let's talk about how we would put this equation in standard form. Something like this. This is what's called standard form of an equation. Something times x plus something times y equals a number. Now, in order to do that, I'm going to rewrite this up here and erase this. So we have in our slope-intercept form, y equals negative 5 over 9, x minus 47 over 9. And again, I'm going to put the y over 1. The first thing you want to do is when you want to put something in standard format, you don't want to have any fractions. So what you're going to do is you're going to multiply everything by the common denominator. And again, we see that the common denominator here would be, there's a 1, a 9, and a 9, so the common denominator is 9. Every number goes into 9. So I'm going to multiply everything by 9 over 1. This will give me 9 over 1 times y over 1 equals 9 over 1 times negative 5 over 9 x minus 9 over 1 times 47 over 9. And this, there's nothing cancels out from the numerators and denominators, so this just becomes 9y. Here the 9's cancel out, and then therefore I just left with negative 5x. And again, here the 9's cancel out, and I'm left with negative 47. And the only thing I need is for it to be in standard form is for everything to be, all the x's and y's to be on one side of the equation, the number on the other side. So I will put plus 5x. I'll bring the 5x to the other side. And in standard format, my answer comes out to be 5x plus 9y equals negative 47. It's just another format. Really, if I'm going to be asking you to write an equation, I will certainly accept the slope-intercept format. But sometimes you'll see on a, not so much on one of my tests, but on the midterm or the final, they may ask you to put it in standard format. And that's how you would go about doing that. Does that explain this problem? Are we okay with this now?
Yes.
Okay now? All right. So I'm going to give you, I hope you started on the Delta math examples. There are a bunch of them that are similar to this. So it's a very important topic. It's a difficult topic, but it's an important topic. Let's just stop for a minute and discuss what's going to be with the test, the first test that I'm giving you. So the first test that I'm going to be giving you is going to be on Delta Math. It's going to be 10 problems. You will not have the ability to try it twice. It's a test, so you'll only get one chance at doing any problem. You do have, if you don't get it right, you do have the option of trying it a second time. I'm sorry, just hold a second. Hello? Sorry about that. You will have, in other words, if you get it wrong, it'll give you the option to try another problem that's similar. If you do the second problem correctly, then you won't get full credit for it. In other words, if there are 10 questions and you get them all right the first time, you get 100. If you do one of them twice, so the first one you got wrong, but the second one you got right, then you won't get 100%, you'll get something in the 90% area. So it'll be 90, it won't be 90, it'll be something more than 90, but if you don't do another one at all and you get the other 9 correct, you get 90%. If you do one and you do a second time, then you're going to get something like 95%. Is it timed? No, I'm not going to give it timed. What I'm going to do is I'm going to open it on for you after class on Tuesday. Tuesday's date is, today is the 10th, so Tuesday's date would be the 15th. I will open it up around 2 o'clock on the 15th, and I will give you a total of 24 hours. You can do, it shouldn't take you 24 hours to do, but I'm giving it because not everybody, I don't know what everybody's schedule is. I'm not giving it during class time. I'm going to first open it for you at around 2 o'clock, and it'll be available until 2 o'clock, maybe 2:30, whatever it is. I'll give you a full 24 hours in order to complete it. The next test that we will have will be a test either given on Blackboard, where it'll be something that will be a time test. But this first test is just, it's on what we call chapters 1 and 2. What we are completing today, that's, I'll tell you, we have one topic that we still have to do, and that's going to be anything from the beginning of the term until what we're going to be completing what's called functional notation. That could be on the test. Is that clear?
Yes.
Okay, great. So now, I'm going to give you one of these to try. I'm going to give you some time to try it on your own, and then we'll work it through together. And after that, I'm going to go on to a new topic. Again, this is one of the questions on this exercise sheet 2. I did resend it for those of you that were having trouble reading it because it wasn't a PDF. I did send it now in PDF form so you can try and look at it again. Okay, here's an example. We want to determine the equation of the line described. This is example number 12. put the answer in slope-intercept form. We want the y-intercept should be equal to -5, and we want it to be parallel to y equals -3x plus 7. I want you to write an equation of this line that has a y-intercept of -5 and is parallel to -7. And I'm going to give you a couple minutes to try this. Okay. I think most of you probably had enough time to work this out. Let's see what we know that our line that we're trying to write the equation of has to be in what we call the slope-intercept form. So we're looking for y equals mx plus b. And again, the first thing I always concentrate on is finding what is the slope of the line that we're looking for. And the fact that we told that it's going to be parallel to this line y equals -3x plus 7, we know that the two lines have to have the exact same slope. In order for the lines to be parallel, their slopes have to be equal. Well, what is the slope of this line? Let's call this line number 1. Here's my line number 2, the one I'm writing. The slope for line number 1 happens to be -3 because this is in the y equals mx plus b form, and therefore its slope is -3, which means the slope of my line, the new line, is also going to be -3. In order for the two lines to be parallel, they have to have the same slope. So it's y equals -3x plus b. What I'm missing still is what is the b? It's not 7 because that's the slope of the y-intercept of the original line. We want a new line, and we know its y-intercept is going to be -5, which means the b on my line has to be equal to -5. That's what b is. It's the y-intercept. So therefore, the equation is y equals -3x minus 5. So this was a much easier problem than the one previous to this. And here was the solution. How many people got this one right? Just either by a show of hands or by on the chat. You can. Okay, Marcus, good, great. Anybody else get it right? Okay, I see Darren. Okay, good, great. I see a lot of you have gotten it right. That's great. Okay, so what I'm going to do is I'm going to leave this topic now. I'm going to talk about something new. And at the end of the period, I will again come back to this and assign you a couple of problems to try in your breakout rooms. Again, nobody from this group has indicated they wanted to be in a specific breakout room, so we're going to just do it randomly like we've been doing. But please, when you're in your breakout rooms, if you can't communicate verbally because you don't have a mic on your device or whatever, at least communicate through the chat so that you can help each other in working these examples out. Okay. Let's just look at this example, this equation, now that we've figured out what the answer is. This is just some regular equation, y equals -3x minus 5. Now, what does it mean that we have an equation with two variables? Usually, if I have an equation with only one variable and it's just an algebraic equation, I can solve it. I can't go ahead and solve this equation. Yes, I can graph it, but I can't solve it because it has two unknowns. But if you think about it, what you do know is if you take any value for x, for example, pick x randomly, any number. Let's say you pick x to be 100. Once you've picked out what the value of x is, then you can solve it for y. Then you can figure out the value for y. This would be -3 times 100 minus 5. And if we figure that out, that gives us -300 minus 5, which is -305. And we sometimes write that as an ordered pair where we'll say 100, comma, -305. What is this telling us? It's telling us if I pick a number for x, in this case, if I pick x to be 100, then I can figure out what the y is. We sometimes call the x what we call the independent variable. I could pick any x to be anything at random. I could pick it to be a fraction. I could pick it to be a whole number. I could pick it to be a million. I could pick it to be -75. I can pick it to be 3/5. I can pick it to be a decimal, 0.0001 if I want. I could even pick it to have something with square roots in it. I could pick any number I want for x. And then once I pick the x, remember it's independent, so I can pick it to be anything, the y is set. Then I stick that number into the equation and the y comes out to be a specific number. The y is what we call dependent variable. It depends, the value of y depends on the value of x. And if we notice in this particular example, as soon as I picked one value for x, there was only one possible answer I could get for y. If x is 100, the only thing that'll work for this particular example is if y is negative 305. If I pick x to be negative 2, then the y will turn out to be negative 3 times negative 2 minus 5. This is negative 3 and negative 2 times negative 2 is 6 minus 5, negative 1. In other words, in this case, when x is negative 2, y is going to be negative 1. Again, I arbitrarily picked the value for x, and then I figured out what the value of y is. There was only one answer to what y could be. Y can be negative, only can be negative 1 if my x is negative 2. Again, I picked anything I wanted for x, but then, because it's independent, but the y is dependent. It's the dependent variable. It depends on the value of x. Now, when we have two variables in either an equation, or it could be in an inequality, or even in a real life situation where we have two different things in the same problem, not always do we have the situation that when you pick your value for x, your first variable, there's only going to be one answer for y. So we want to give that a special name. We call an equation or a situation in which, just erase. What was this? I'm just rewriting this. The situation in which for each value of x, gives us exactly one value for y. If we have such a situation, this was an example of that, each value I picked for x, I got one answer for y. That type of situation is what we call a function. Anytime I say, oh, this is a function, or this is a function of x's and y's, what I'm telling you is that I have an equation with x's and y's, and every time I pick a value for x, I'll only have one answer for y. Every value of x that I give you will give you exactly one answer for y. And this is, in math, actually the preferred situation. We'd like to always have it, it doesn't always work, but we'd like to always have a situation where one x gives us one y. So my preferred situations that I prefer working with are cases in which we have functions. And sometimes to indicate that what we have is indeed a function, we use something called functional notation. Instead of using y, in place of the y, we use something that it's called f of x. It's written f parentheses x. It's read f of x. Now, this symbol, f of x, is no different than the y. It's just a different name for y. The advantage of it is that I know that when I'm dealing with f of x, I know I'm dealing with a y, but it's a y where every value of x gives me exactly one value for y. So instead of writing y equals negative 3x minus 5, we could write f of x equals negative 3x minus 5. So it's just another name for y, but it's a name for y that gives me some information about the kind of equation I'm dealing with. I know this equation is a function. Now, there are a couple of other advantages of this functional notation. First of all, let's say I have two different equations in my problem. I have example 1, y equals negative 3x minus 5. And I have a second equation, let's say it's y equals 2x plus 1. Now this is very confusing. If I say, what is the value of y when x equals, I'm writing this out, what is y if x equals negative 1? Well, that's a very hard question to answer, because do I mean this y or do I mean this y? If I have two equations in the same exact problem, how do I know which y I'm talking about? Well, I can solve that situation by using my functional notation. In other words, I can call my first equation f of x. And then my second equation, instead of using f, I can use a different letter. Usually the letters we use for functions are like f, g, h. I can call the second one g of x. And therefore, it's very easy to differentiate between which equations I'm talking about. I can say, find the value of f of x when x equals negative 1, and you'll know to go to the first equation. Whereas if I say find g of x when x equals negative 1, you know to go to the second equation. It's a way of giving different names to two different y's. Now that doesn't always happen. There is even an easier way to write this. I can say if f of x, I'm going to just put this a little lower. I can say find f of negative 1. Notice there is an x here. What this x here is telling me next to the f or next to the g is that the independent variable I'm using is x. My equation is going to be an equation with x. Whereas if I tell you to find f of negative 1, what I've done is over here, I've replaced my x with negative 1. So that means go to the other side and replace x with negative 1. And this again gives us negative 1, 3 times negative 1 is 3 minus 5, which gives me negative 2. To say that f of negative 1 equals negative 2 is telling me in my function f, this function, this equation, when I pick the x to be negative 1, the y is going to be negative 2. F of negative 1 means the y value when the x value is negative 1. In other words, the point on the line would be the point negative 1 comma negative 2. Similarly, if I ask you find g of negative 1, that means go to the equation that has g in it, and wherever I have an x, replace that x with negative 1. So that would be 2 times negative 1, plus 1, which is negative 2 plus 1, which equals negative 1. In other words, in the g function, when x is negative 1, the y turns out to be negative 1 as well. So this is how we use functional notation. It gives us, it's clearer because we know exactly which equation we're looking at, and it's easy to say. Instead of saying, what is the y value if x equals negative 1? All I have to do is say, find f of negative 1. That is telling you the same thing in a much more efficient and quick way. Let's see if you understood this. Let's say I gave you this question. Okay. Suppose I give you, this is question number 21. Suppose I tell you that f of x is equal to 3x squared minus 2x minus 10. And I want you to find three things. I want you to find f of 2. I want you to find f of negative 2. And I want you to find f of 0. Okay, I'm going to give you a few minutes to try this while I take attendance. Okay. If possible, answer me. If not, send me a chat that you're here so I know that you're here. Okay, Ray Adams. Ray Adams here? Lukey Aguero. Lukey?
I'm here.
Okay. Farhas Anzum. Farhas?
I am here.
Okay. Justin Brewster.
Here.
Okay, great. Jordan Calendar. Jordan?
Here.
Oh, good. Pretty picture. Halima Kamara.
Here, good morning.
Good morning. Kaimani Clark. Kaimani?
Here.
Oh, okay. Shanice Craddock. Shanice? I think I saw you sent me a, yeah, you're here. I see you sent me a chat. Carmelita Cross.
Here.
Monette Daniels. Monette. Darren Dasney. Darren, I saw once before. Yeah, good. Cheyenne Duncan. Cheyenne? Cheyenne Duncan here? Tiamani Farron. Tiamani? Tiamani here? Stephanie Fuentes?
I'm here.
Okay, good. Tyler Graham?
Here.
Good. Tashawn Gutierrez? Tashawn? Tashawn, are you here? Tashawn?
Hello.
Oh, Kaimani, I see. Tiamani, okay, you just came on? Tiamani, I got you.
No, I didn't just come on. My connection wasn't working, so I kept going off and on.
I'm sorry, I didn't hear what you said. Tiamani, you had something you wanted to, I'm sorry, I didn't hear what you said. Okay. Ariel Harvey, Ariel Harvey. Ariel Harvey here. Hoda Hassan. Hoda? Okay, see you're here, good. Caesar Hicks. Caesar? Diamond George. Diamond?
Here.
Good. Okay, we're getting there. Zanaya Jenkins, I see you said your audio isn't working, but you're here, great. David Johnson, I know you were first one.
I'm here.
You're here, so you. Eureka Jules, Eureka Jules. Jefferson Lane. Jefferson. Kylie. Kai. Teresa Lindsay, I see you're here. Kartana Nath.
Hi, I'm here.
Okay, good. Faria Noor. Faria Noor. Faria. Asosa Odemwingi.
I'm
Asosa.
here.
Oh, okay, good. I have you absent. Asosa, I have you absent for 3 times. Is that correct?
I was absent twice.
You came once before?
Yes.
Okay. Jennifer Passio. Jennifer. Jennifer here?
I'm here.
Okay, good. Raymond, Theodore Raymond. Theodore. Theodore? Okay. And I do see, Ray, that you're here, and I had you marked absent, so I'm changing that. Ray. Amy Sandoval. Amy.
I'm here.
Okay. Hey, nice to see you.
Hi.
Evelyn Sola. Evelyn. These are my people who are always here. Evelyn. Cheyenne Short. Cheyenne.
I'm here.
Okay, good. Aisha Silla. Aisha.
I'm here.
Okay, good.
Yeah.
Donasia Sirleaf. Donasia Sirleaf. Donasia here. Daryl Stewart. Daryl Stewart. Okay. Camille White. Camille. Camille White. Martin Williams.
I'm here.
Okay, good. Nikisha Williams. Nikisha.
I'm here.
Okay. Marcus Williamson, I know you're here because you've been asking me questions. Good. Snapfair Laborde. Snapfair.
I'm here, Professor. Good morning.
And Yoel Johnson.
Here.
Okay, great. Okay. So let's go back to this question. Okay. So to find out what f of 2 is, what we have to do is replace the x with 2. So we're going to be doing 3 times 2 squared minus 2 times 2 minus 10. Notice when you're replacing something like x, you have to put it in parentheses, because if you didn't put if you wrote 2, 2, it would look like 22. So wherever there's an x's, we're putting a parentheses and replacing it with a number that's over here. We're replacing x with 2. Now be careful about this. Let me just put it over here. I'm going to have to move these things down. This is a matter of just being careful with your arithmetic and remembering your order of operations. Again, if you want, you could stick this into your calculator. And if you stick it into your calculator, put in the parentheses and it'll work out perfectly. Remember, when you're doing something with an exponent, the first thing you have to do is the exponent. So it's 2 times 2, which is 4. And then you multiply it 3 times 4. So that first term becomes 12. This is minus 2 times 2, so that's minus 4. And this is minus 10. So 12 minus 4 is 8, minus 2 is 10 is negative 2. So it turns out that f of 2 equals negative 2. How many people got that answer correct? Did you get this correct? Okay, great. I see
Yeah.
a lot of people did. Okay. If I want to find out what f of negative 2 is, I do the same thing, but in place of with the x, I'm going to do negative 2. So this is going to be 3 times negative 2 squared minus 2 times negative 2 minus 10. Now be careful again. Remember, you do the exponent first. Negative 2 squared is negative 2 times negative 2, which is positive 4. So this is 3 times positive 4, which is 12. This is negative 2 times negative 2 is plus 4, because a negative times a negative is positive, minus 10. And 12 plus 4 is 16, minus 10 is 6. So it turns out that f of negative 2 happens to be 6. That means if I pick x to be negative 2, the y value, the f of x is the y value is 6. Finally, f of 0, we have to replace x with 0. So it's going to be 3 times 0 squared minus 2 times 0 minus 10. Now, when you replace x with 0, any place you have a 0, it's going to turn out to be 0, because 0 times anything is 0. So this will be 0, this will be 0. The only thing that's not 0 is this negative 10. So your answer is negative 10. F of 0 equals negative 10. If I would have graphed this, and this is not a straight line because it has an x squared, we're going to be talking about later in the term what type of figure we're going to get when we graph something like that. But I know if the x is 0, the y is negative 10. That means the y-intercept is negative 10 because we get the y-intercept when the x is 0. So we'll see that one of the things we can always find on a graph is x and y intercepts. Any questions about this? About how to use this functional notation? Okay. Okay, great. This could be even a little bit more complex than that. Let's say I gave you something like this. Suppose I gave you h of x. Remember, I don't have to only use the letter F. I could use H, I could use G, I could use any letter I want. I could call it R of X. Again, H of X, let's say it's equal to 3x minus 1. If I asked you to find H of 5, that would tell you wherever, go to your H equation, which is right here, and wherever you see an X, replace it with 5. So you're going to get 3 times 5 minus 1, which is going to give you 15 minus 1, which is equal to 16. H of 5 equals 16. Nothing new there. But what if I asked you something like this? Find H of C. That's strange. I've always put a regular number here. Now I put a letter. But you do the same thing. You go to your original equation, and wherever you see an X over here, you replace it with a C. So this is going to be 3C minus 1 instead of 3x minus 1. What if I asked you to do something like this? Find H of 2A. It's also a little strange, but the idea is the same. That means go to your H of X, and wherever you see an X, replace it with 2A. That'll mean this is equal to 3 times, here's your X, 2A minus 1. Well, in this case, we can actually simplify this further. 3 times 2A is 6A minus 1. So H of 2A is equal to 6A minus 1. I could even do something like this. Find H of X minus 1. Well, this is really strange. This is what H of X is. And I want to find out what H of X minus 1 is. What is that telling me? It's telling me wherever I have an X, replace that X with what's in here, which is X minus 1. So this is going to be 3. Here's my X. What am I putting in place of X? X minus 1. This was my original X. I'm replacing it. It's not a multiplication. It's a replacement. I'm replacing X from the H of X with x minus 1 because I want to figure out what h of x minus 1 is. So it's 3 times x minus 1 minus this 1 from over here. And again, we could simplify this. This will be 3x minus 3 minus 1, which gives me 3x. And negative 3 and negative 1 is negative 4. So h of x minus 1 is 3x minus 4. I'm going to give you one to try. See if you get this idea. Here's what I'm giving you. Find f, this was actually off of one of the previous finals. Find f of 2x when f of x is equal to negative 3x squared minus 4x plus 3. And I want you to simplify this as much as you can. Find f of 2x when f of x is negative 3x squared minus 4x plus 3. Okay, I'm going to give you a couple minutes to work on that. Okay, let's see if we can work this out together now. What does it mean to find f of 2x? It means, and I'm going to put a circle around each one of them, every place I have an x in my original equation, which is here and here, those where I see those two x's, I'm going to take those x's out and replace them with 2x. So here's what it's going to be. Here's what my f of 2x is going to look like. It's going to be negative 3. Okay, here's my replacement. Originally I had an x there. In place of the x, I'm putting 2x. So this is 2x squared. Here's my original x. Minus 4. Here's my next x. Remember, I put a parenthesis where the x is and fill it in with 2x. And then there's a plus 3. All I've done to find f of 2x is replace wherever I saw an x, I replaced it with 2x. And now I have to be careful to do this work correctly. Remember, I always do the exponents first. Now this says, I'm just going to do this on the side, 2x squared. Now remember what 2x squared means. It's not just the x is squared, it means the 2x has to be multiplied by itself. It's the 2x times the 2x. So this is going to give me 4x squared, because 2 times 2 is 4, and x times x is x squared. And that has to be multiplied by my -3. Remember, the exponent I took care of, so now I'm going to multiply by -3. That will give me -12x squared. The next thing I have is a -4 times a 2x. So that'll give me -8x and plus 3. And these are not like terms, so here is your final answer. How many people got something that looks like that? So it's a matter of not only understanding what functional notation about, is also being careful with the algebra, the working out of the question. Now, what we have covered through now is what will be on that first test. Everything from the beginning of the term, which is going to include equations, linear equations, equations that have fractions in them, equations that have decimals in them, inequalities, how to solve an inequality, how to draw it on the number line, how to put it in interval notation. There's going to be questions on absolute value equations, and then there's going to be questions about graphing and about writing equations of graphs, and there's going to be questions about this functional notation. There's going to be a total of 10 questions. Again, I will let you know exactly when the test is going to be available. It's going to be available starting after class on Tuesday. I will give you 24 hours to complete it, and you will get just each question. Instead of getting 2 chances to do a question, you only get 1. But if you get it wrong, you can do another one. You won't get full credit then. In other words, if you did 2 questions and it was worth, if the question was worth 10 points, you won't get the full 10 points. You'll only get like 7 or 6 of the points. I don't remember exactly how it works. So again, look on Delta Math for your first test on Tuesday after class. I'll remind you on Tuesday after class about it. Okay. I'm now starting a new topic. We have about a half an hour left to class. And I'm going on to what's called chapter 3 in the book. This is what's called systems of equations. I'm just going to introduce the concept today. We will continue with it on Tuesday. Again, on Tuesday, at the start of class, if there are any topics that you want me to review, because it's going to be on the test, either send me an email before class, or in class when I start, you can let me know. Okay. And let's continue with this. What is a system of equations? Something like this. In a system of equations where we will have 2 variables, instead of having just 1 equation, we'll have 2 equations. And we're going to be doing something called solving of systems of equations. If we had we won't deal with it here in this class, but you could even have a system of equations where you would have 3 variables, an x, a y, and a z, and 3 equations. You always have to have as many equations as you have variables. Now, Let me explain to you what we mean by solving a system of equations. We're going to do this in a minute, but let's theoretically talk about it. These are each linear equations. What do linear equations do? A linear equation is called a linear equation because it represents a line. So let's say one linear equation gives you a line like this. Let's say that's equation number 1. This is not, it's not this one because we haven't worked that out. And let's say equation number 2 looks like this. And we're drawing them on the same piece of graph paper, or this, what we call the same axes. There are 3 different scenarios of what could happen. The most common scenario is that you get 2 lines that intersect, the 2 lines cross. And to find the solution is the point where they meet. The point of intersection is called the solution, is the solution of the system of equations. So when I say solve the system of equations, what I'm basically telling you to do is find where the 2 lines meet. They meet in a point, so you're going to have an x value and a y value, and both of those values work in both equations. We're going to try that in a minute. That is not the only thing that could happen, though. This is what when we get one point where they meet, and they can't meet in more than one point because they're straight lines. This is what's called a consistent system of equations. Something that looks like this. Now, it might be, what could have happened is that when you drew your 2 lines, you got something like this. The 2 lines are actually parallel lines. They never meet. There's no solution here because there's no place where they meet. This is what's called an inconsistent system of equations. And if I ask you what is the solution, there is no solution because there's no point where they meet. That's why it's called inconsistent. You will actually be able to tell this ahead of time because how can you tell if lines are parallel? If you look at their slopes. If their slopes are the same, then they must be parallel lines. I could actually, just if I looked at my 2 equations and I saw that I had 2 lines that have the exact same slope, their y-intercepts are different, but their slopes are the same, I don't have to do any work if I want to solve that system of equations because it's not solvable. The lines are parallel. They have the same slope. So it's an inconsistent system of equation. It does not have any solutions. So that's not so common. Most common is there was one point where they meet. That point of intersection is what's called the solution of the system of equations, and they're consistent. That's a consistent system of equations. There is a third scenario. What is the third scenario? Here's what could happen. I draw my first line, say get something like this. Here's line number 1. And then I go to draw my second line. And it turns out that the second line lies right on top of the first line. The 2 lines are actually not 2 different lines. The equations didn't look exactly alike when we started, but when I started working with them, I saw that both equations gave us the exact same line. In that case, we have what's called a dependent system of equations. because it isn't two separate equations, it really is just one equation. Both equations are actually the same. Now, if you think about it, how many points do these two lines meet? They meet on every single point. In other words, there's an infinite number of solutions in a dependent system of equations, because any point that's on one line is on the other line as well. Any point on the line is a solution for both equations. So it has infinite solutions. That's what we call a dependent system of equations. I would say that's the least common scenario. Okay, I want to take this system of equations and actually work it out graphically. What we're going to learn on Tuesday is that there are even quicker ways that we don't have to do it on the graph. We don't have to go through the whole graph. We can solve the system equations, what we call algebraically, but that's for Tuesday. For today, we're going to look at the system of equations right here. 3x plus 2y equals -6 is one equation. Let's call that equation number 1. And my second equation is y equals -x minus 4. And we're going to try and graph both of these lines and see if we can find the point of intersection, the point where they meet, and that'll give us the solution to the system of equations. Okay, let's try graphing number 1. Graphing number 1, 3x plus 2y equals -6. Now, if you remember, there are two ways we can graph lines. One, we can do the intercept method, and one, we can do the y equals mx plus b, the slope-intercept method. There are other methods, but those are the ones that we discussed here in class. This one looks like a perfect setup for finding intercepts. So let's do this one by the intercepts, and let's do this one by the slope-intercept method, so we'll have both methods covered, and we'll remember how to do them. Remember, to find an x-intercept, what we do is we replace y with 0. Now I'm going to put the graph over here, let me put it over here so I won't use up the space. When y equals 0, if I replace the y with 0, I'll get 3x. This part is 0, so I don't have to put it in, equals -6. And if I divide by 3, that gives me x equals -2. In other words, my x-intercept is the point -2, 0. When the x is -2, the y is 0, and that's right here. X -2, y 0, right here. Okay, my second thing I do here is I find the y-intercept. Now, how do I find the y-intercept? I do that by setting x equal to 0. In this equation, if I replace x with 0, this will be 3 times 0, which is 0, and that'll just give me 2y equals -6. And when I divide by 2, that gives me y equals -3. So my y-intercept is 1, 2, 3 down, and here are my 2 points on my line. Here is my line. This is line number 1. We have graphed line number 1. Okay, I now want to graph line number 2. Can I erase this now? Everybody okay with my erasing this? Okay. So let's try line number 2. My second line is y equals negative x minus 4. It already is in what we call the y equals mx plus b form. What is the slope of this line? Well, the slope of the line is a number that's in front of the x. There's no number there, so it's understood as if there's, remember when there's no number, it's understood as if it's 1. So therefore, my slope is negative 1, which is negative 1 over 1. Remember, if it's a whole number, we put it over 1, so that we have the slope is negative 1 over 1. The y-intercept is the number that stands alone, that doesn't have any x attached to it. So the y-intercept is negative 4. How do we use that to draw the y? Well, remember how we do it. We go first to the y-intercept. Let me see. I'm going to try it with a red, so I hope this comes out. 1, 2, 3, 4. Here's my y-intercept. And my slope is negative 1. What does the slope of negative 1 mean? It means you go down 1 over 1. Or vice versa, you could go up 1, but then 1 to the left. And you get something that looks like, if I draw it, it looks like this is it. Now, of course, this would be much better done if I had a piece of graph paper. The solution is right here. The point where the two lines meet. Now, it looks to me as if this is the point. I think I've done something wrong. Maybe x is 2. Y is negative 4. I think that's what it looks like. No, it can't be 4. Should be maybe it's 6. Maybe it's down 6. I don't know. Negative 5. 2 times 6. I think this is probably a negative 6. Maybe it's down negative 6. Notice I count, this looked like it's 2 over and 1, 2, 3, 4, 5, 6. Notice if this would have been on a piece of graph paper where I could have seen the boxes, but the point where they meet is the point 2, negative 6. What does that mean? It means that if I replace in each equation the x with 2 and the y with negative 6, I'll get a true statement. Look at this. At 3x plus 2y equals negative 6, 3 times 2, I'm replacing the x by 2, plus 2 times negative 6 will give me 6 minus 12, which is negative 6. That works. And the first equation, negative y equals negative 1x minus 4 is negative 6 equals negative 1 times 2 minus 4, which is negative 2 minus 4, which is negative 6, and that works. So both of these work. This is the solution of the system of equations. x equals 2, y equals -6. You can write it this way, or you can write it this way, but the solution of the system of equations is the point where the two lines meet. Now notice it's a lot of work because you have to be very careful in your graphing. Again, if you want to do this on a, you should take out a piece of graph paper and a straight edge, either a ruler or something that can make a straight line. Because if you notice, you'll run into problems like I did, that it's very hard to figure out where are they meeting. What we're going to do is see that there are other methods that can be used to solve systems of equations. But again, a system of equations is a set of two equations where you have two variables, and what you're searching for, what you're solving, is the point where the two lines meet. Does anybody have any questions they'd like to ask me? If not, I'm going to start recording right now. I'm not going to go any further now. I'm not assigning you problems from practice sheet 3 yet. I want you to concentrate on doing everything from the first 2 chapters, the chapter on equations, inequalities, and absolute value equations, and the chapter on graphing of linear equations and writing their equations, and functional notation. All those, make sure that you're doing the Delta Math homework. And again, your test is going to be on Tuesday on Delta Math. Any questions before I close class?
When is the Delta Math due?
Each one, it tells you exactly. Look at on the Delta Math. Each one, there were 3 assignments. They're all due on different dates, but I did extend the dates. Okay? Go to Delta Math and it will tell you specifically when your assignment is due.
Okay.
Any other questions? Let me just mention that there is a SI, a supplemental instructor, that is assigned to our course. I sent you her times. She hadn't given me her login information, but she has sessions, and I sent you the schedule with her sessions. She will help you with some of these problems if you're running into problems. Again, it's very important that you be able to know how to do all the examples on the practice sheets. The practice sheets are from the department, and that's what they use as a basis of writing their midterms and finals. I mean, basically, of course, I am going over that, but you should know that that's the important thing. Again, this test will be on Delta Math. The next test will not. It will be a test where you're going to have to submit answers to me. Okay? Any other questions? All right, have a good weekend and work on your examples. Work on your Delta Math. There's tons of examples, and I used the exact same example set for your test. So if you know how to do if you practice the homework, you should have no problem doing the test itself. Okay, any questions? Okay, then I'm gonna stop the recording. Yeah.